Hello and welcome to this afternoon's live session here live from Raspberry Pi Towers in Cambridge. We're today going to be talking a little bit about moving our students from blocks to text. I'm James Robinson. I'm going to be your host for this live learning session, and we're going to go over some learning objectives in just a moment. What I'd like to do first of all is I'd like to get you talking to each other. So I'm going to go back to my slides, but I'm going to just skip ahead very briefly and just give you some information on how you can interact with us today. So if we just go back to the slides. So there's a couple of ways that you can participate in today's session. The main way that we'd like to see people engaging with us and answering questions is by using a Menti poll that we have set up. And we're going to be using this poll throughout our session. So if you go along to Menti and you go and you enter a code 927842, there is a question there that I'd like you to start thinking about as we introduce the session. You can introduce yourself and tell us a little bit about why you think moving students from blocks to text is important. So go to menti.com and go 927842. And you can do that on your mobile phone, via the app, or on the web. Okay, so whilst you're doing that, I'm going to spend a few moments just introducing the session. So I'm going to go back a couple of slides and we're going to talk about the things that I want to talk about throughout the next 40 minutes. So during this session, we're going to spend some time reviewing the range of block and text-based programming environments. And there's a whole selection of them out there that we could investigate. And then we're going to focus specifically in this session on Scratch and Python. We're also going to spend a bit of time thinking about some of the difficulties that our students might face as they move into text-based programming. Many of our students are very familiar with Scratch and other block-based environments. How do we sort of wean them off Scratch and move them into something that's text-based? And then finally, we're going to have a look at a few strategies that might aid this transition. And we're going to look at these difficulties and strategies both in terms of the language itself, Scratch and Python, and the specifics of the languages and what challenges they present, but also the challenges and strategies we might use to specifically support our learners and the issues that they might bring to this challenge themselves. So we're doing this course at the moment because it connects really nicely with our online FutureLearn course. So we have an online FutureLearn course that's running at the moment where we are spending 4 weeks looking at exactly this topic. There's lots of discussions, reflections, and things that we can talk about there. So if you're not already participating in that course, you should go along to rpf.io/train online, where you can sign up for the course and start participating. Great, so it looks like we have a few people joining us at the moment via Menti. So we're just going to nip over to the Menti deck and we're going to have a look and see who we've got with us. So we've got a primary teacher here, who's a Raspberry Pi certified educator. They're interested in the transition from primary to more secondary-based coding. We think someone's says that they think block-based programming is easier to program and check errors, if any. We've got Beverly, who's saying it's important to develop their skills and prepare them for code formats that they will find in the workplace. That's a really important point, Beverly. Thank you for making that. Scratch is a really great language for learning, but there's very few applications for it in industry or in the workplace. That's great. We want to get them to move out of their comfort zone and into text-based coding. Yes, also, however, text-based coding needs to get better. And we'll talk a little bit about some of the efforts that are happening in that space at the moment. We've got Dad of Two is an engineer who's running a code club. Well done. And you want to go from graphics basics to real coding within the same projects. We've got a library associate running coding and tech programs for children. We've got a few people joining us. That's great. And hopefully we'll have a few more people as the session goes on. Fantastic. Okay, so let's go back to our slides now. We're going to talk a little bit about some of the languages that are available out there. We've spoken a little bit about how to participate. And I should have mentioned as well, we have the live chat on YouTube. Feel free to kind of chat in there. That's not something that I can see where I am at the moment. So if you want to ask me a question or share something, the best way to do that is through Menti. In your interaction panel, you've got ask a question. And if you want to interrupt or ask something, that's the way to do it. Great. OK, so We've answered that question, so let's move on to programming models. So we talk a lot about block-based programming, and this really encapsulates a whole range of languages. And I'm just going to pick 3 examples that I've used in the past. So we have Scratch, and when I talk about Scratch, we're talking about Scratch 1, 2, the future release Scratch 3, we're talking about Scratch Junior, all of the sort of different variants of Scratch. And that's a really sort of popular language, lots of people are using that. We're also talking about things like Alice. Now, if you're using Alice, it'd be great to hear from you, or any other languages that you might have used. And there's also this robot image here. This is Kodu, which is a really popular language in lots of primary settings or elementary settings. And that's a nice language that we can do some sort of game playing exploration through block-based programming. And then sort of at the opposite end of the spectrum, we've got our text-based programming languages. And again, there's a whole range of those. I've just picked 5 of those to sort of illustrate the point. We have Python, which is proving very popular in education at the moment. We have Ruby, which is another popular language. C++ is a sort of mainstay of programming, really important language that lots of programming is done through, but it can be quite hard to get into sometimes. JavaScript is a fantastic tool for website sort of work and scripting online. And then we also have Java here, which again is a sort of really significant industry language. But again, there's some concepts that you have to get over before you get into Java. You have to understand a thing called object orientation before you can really start with Java. So these are all great languages, but they take a little bit of time to get into. They all have very practical uses. And then we have this sort of interesting middle ground where we have languages like Blockly. And many of you will be using languages, either Blockly in itself or languages based upon Blockly. Blockly and its sort of other similar languages like that are really nice. They have a sort of multimodal approach in that you can write programs using blocks, but then you could also see the code that goes behind them. And what's really nice is that these blocks can be tied to Python or C or Java or a multitude of languages. And so this symbol here, many people will have used this if they've got microbits. This is Microsoft's Make code. And this is an implementation of Blockly. And when you look behind the blocks, you can see the raw JavaScript code behind the scenes. And this is a language written by a young lad from the north of England called Josh, and this is EduBlocks. And this, similar to Make code, this allows you to create Blockly scripts, but behind the scenes, you can see the Python code. And the idea behind these languages is that you can program in blocks, but you can make those connections with the text-based structures and concepts that are used behind them. Great. We have a few more people joining us. We've got Stuart, who's a co-club volunteer, and a few other individuals. We've got Tony. So that's great to hear from you guys. So let's have a think about what the barriers are. And we're going to go back to Menti for this question. So I'm going to open up another Menti poll. And the question that I want to ask is about the barriers that you perceive there being to learners engaging in text-based programming. So is it around the expectations that they might have? Is it to do with syntax and spelling? Is it understanding the equivalence between the Scratch concepts and the Python implementation of those concepts? Is it around the learners themselves and their own resilience, or perhaps their motivation? Or are there some other issues that you think are at play here? Please spend a few moments just rating each of those barriers and then submit your answers. If you want to share another barrier that you think is relevant, then you can do that via the Ask a Question button. And I'm really interested to see where you perceive these challenges to be. And I think we're going to talk a little bit in a moment about each of these. Particularly, I think first of all, we're going to talk a bit about the language equivalence, syntax and spelling, but we're also going to talk about the learner's individual needs. Okay, we've had one response so far, which sort of suggests, if we go over to the Menti now, we can see that we've got, syntax and spelling seems to be quite a common thing so far, or based on our large sample of 2, 3, 4. Syntax and spelling seems to be quite important, but equally, there are some other factors at play here. So learner resilience comes out quite high, which is interesting. as does expectations of what's possible, and we'll cover that later on. Motivation's quite key, and interestingly, there are few other barriers that people think are sort of relevant here. Okay, that's cool. I'm going to leave that ticking away for a moment until we come to our next poll. So do feel free to spend a few minutes reflecting, if you haven't already, and filling that in. And that data is really interesting for us as well. So thank you very much for that. So let's look at some of the language issues that we might have in this space. So we're going to go back to the presentation, and we're going to talk about a conceptual model for how students learn to program, called the block model. And the block model, if you've read any of the recent literature, this is actually from 2008, it's not that recent, but there are some sort of thinking around, some thinking going on at the moment around how students are learning and how we can kind of conceptualize the different the different perceptions of programming that students might have, or the different sort of levels or layers within it. And so this is adapted slightly from a model proposed by Carlson Schultz in 2008. And by adapted, basically, I've changed one of the words from blocks to chunks, because if we're talking about block-based programming and then conceptual blocks, those might get a little bit confusing. So this block-based model allows us to think about writing code in a few different ways. So first of all, when students come to coding, they have to deal with the code surface. And this really relates to the bit that we've just highlighted in the poll. This is about the syntax and the spelling, the text surface, what that code looks like. And there's an aspect of interpretation that the students have to do before they can even start to operate in that space. Now with Scratch, the code surface is colorful, snap together blocks. The sort of the language and the grammar of Scratch is visible, it's really clear to see. They don't need the literacy skills in order to engage in it. The next sort of view on the program is the execution. So this is, as we look at codes, we understand how that code operates. So we can look at a statement and we can say, this statement is outputting a variable, or this is asking for user input, or this is doing this. We can understand how the execution is working. And then finally, the high kind of level, the most abstract level, is understanding the function of the code. So the net result of that line of code, that section of code, or the whole program. And so actually what students struggle with, I think, when they move into block-based programming is they spend a lot of time at this level, having to interpret the code surface before they can start thinking about execution, let alone the overall function. And then the other dimension to this is we have the different sort of elements within our code. So Schultz talks about atoms, and atoms are the smallest chunks, the smallest pieces of the language. And in Scratch, that's a block. So here we have an example of a simple block in Scratch, and that is that's our smallest unit, and that is called an atom when we're talking about it in this context. And then above that, oops, gone the wrong way. Above that, we have this concept of a chunk, which Schultz calls a block, but I'm going to call it a chunk for now. We have this chunk, and a chunk is a selection of atoms combined together to perform a specific function. And so here we have this chunk of code that's going to move a character if the number of lives is greater than 0. And then the level above that, or the next sort of step up from that, is we have relationships. So each block or each chunk of code that we have might have interdependencies or relationships with other chunks of code. So here, these two chunks are related, they're interdependent. When the lives run out, then something stops happening. Okay, so these two chunks are related. And then above that, we might have a whole program where we've got many atoms combined into different chunks, related in different ways, all performing an overall program and an overall purpose. And this is a really interesting kind of model of how we think about programming. And I think what's really important is that this point that students often struggle with working out, they're working at the code surface level, and they're having to deal with the atomic kind of nature of the code they're writing and understand those small elements. And that means that they have to kind of almost take a step back, and they sort of take a step back from the function and the purpose of the code they're writing. So what I would suggest is, and we're going to look at Python first, but I would suggest that we look at equivalence between the two languages. So if we look at Python, we have some challenges. Here's a simple line of Python that's going to ask for some user input. And we're going to have to, we're going to store that into a variable. Now, if we look at that, actually that line of code is made up of smaller elements. We've got a variable, we've got a function name, and we've got a string. And that line is peppered with symbols that give meaning to that statement, but the students have to interpret and understand. And that can be really challenging because now the atoms are smaller constituent parts of a statement, and that can become a challenge for them. And also, like things like chunks, within the chunks that they have, some atoms are dependent on others. In Scratch, if I put in an empty loop, Scratch doesn't care. In Python and other languages, if I miss the conditional element from within inside that loop, then Python's going to complain because it does not know what's going to happen in that loop. So you have this sort of interdependency between the atoms. And then when you get into thinking about the macro structure and the relations, whereas in Scratch, everything's laid out in a very visual way, you can see chunks of code next to each other and see the relationships. In Python, you might just have one long text file. And so that can be really, really challenging for students. And so we have to think about how we break those barriers down. And I think one of the ways in which we might do this is by identifying equivalence. So we might look at our Scratch and Python code and try and identify equivalent concepts and almost look past some of the details, some of the syntax, and just think about function. So the question is, can we use students' fluency with Scratch to scaffold their understanding of Python? Well, I think we can. So I think initially students should look past the syntactic elements and focus on the function and what the code is doing. And so, for example, when we're looking at this, we should equate these two statements. So rather than comparing atoms with atoms, we should be comparing this block with the overall function that it's performing. So say hello world, which the students will be able to do in Scratch, is equivalent to printing hello world in Python. And we can draw out lots of equivalences. And if you take part in the FutureLearn course, that's what the lead educator, Mark, spends a lot of time doing, is trying to draw out these functional equivalences between Scratch and Python. And we're going to dig into that in a moment. We're going to do a little quiz activity and see what your understanding of Scratch and Python is. But also there's things around the making concepts explicit. Concepts are the things that bind together all those languages that we've talked about. And if we can discuss and highlight those concepts, then we can help learners connect Scratch and Python or Blockly or C, whatever the language is. Those concepts are core and fundamental. So let's draw them out, let's make them explicit, and let's highlight those. So there's a lot of focus on writing code and implementing code, but we should also be talking about it and thinking really carefully about those concepts that happen within it. And a nice way to do this is let's annotate our code. Let's annotate Scratch. You know, there's lots of projects that you see on that are produced in Scratch that don't feature annotation. And actually, it's a really nice way to draw comparisons between the functionality in Scratch and the functionality in Python. Now, that's not to say that in every project that students write, they have to go and annotate every single block of code. But you might ask your students, for example, to go and annotate a concept. They might go and find an example of a variable or some assignment or a loop within their code and annotate it. And then when they go into Python, they do the same kind of thing. And so we use the language of the concepts to connect the two languages. Okay, so what we're going to do now is we're going to go and we're going to have a little quiz, because I think you guys have been listening to me waffle on for quite some time. We've got a couple of questions coming in, actually, so I'm just going to address those really quickly. So first of all, we're just going to keep on me. We're not going to look at the questions here, so we're just going to keep the camera here for a minute. So another barrier that somebody else identified is that to the pupil, it can feel like a step backwards. You know, we've been doing all these great things in Scratch, and we take a step backwards, and we can write simple text programs in Python. And we are going to address that barrier a little bit later on. That's a really interesting and valid point. And then somebody mentioned that they're using something called Piper, which is a really nice tool that you can use on the Raspberry Pi. and what they do is they can switch in that program, just like you can in Blockly, between the blocks and the Python. You can toggle between those and see those equivalences. So I think this idea of drawing equivalences is really relevant. So we're gonna delve in now. We're gonna have a look at some equivalences and see how well you do. So we are going to. I've got a few questions here, and for each question, we're going to switch to the slides now, please. For each question, I'm going to give you a few options, and I'm going to give you a short period of time in which to answer them. So your first question, which looks a little bit weird on my screen here, but there we are. Which line of Python is equivalent to this Scratch block? So we have say lives in Scratch. And I would like you to tell me which of those 4 lines of Python is that equivalent to? So I'm going to give you a few moments to do that. Although weirdly on my Menti poll, I'm only seeing 3 options, which is interesting. So we'll see what's going on there in just a second. Okay. So I'm going to give you 10 more seconds, and then I'm going to close that poll, and we're going to have a quick look at the results. Okay. So let's have a look at those results. So Alex, if we just jump over onto the results. Great. So we've got here, we've got a range of responses there. The middle option, print lives, which on my slide was C, that is definitely the most popular, okay? But we also have print in speech marks lives being, this one over here, being answered there as well. And we also have a few people opting for this one. Okay, what I'm going to do now, I'm going to see if, having seen what other people think, I'm going to see if that affects your opinion of this question. So what we're going to do is I'm going to re-ask that question. I'm going to give you no indication of what's correct or what's not. So I'm going to clear the result for this question, and I'm going to ask you to answer that again, okay? And see if having seen other people's results has changed your opinion. And I'm going to give you just 10 seconds to do that. So get your votes in quickly. I might have lost your motivation for voting again. Right, we've got 2 votes, and we have a split decision. Oh, okay. So maybe I should have given you a little bit longer there on that vote. Okay. Well, what I'll do is, what I was trying to do there was a little thing called peer instruction. It's not quite the same because we're doing it remotely, but the idea is seeing how other people vote and then maybe having a discussion about it, which admittedly you didn't have, means that you can kind of refine your decision-making process. Now, the answer is in fact live, this middle one here, print lives. And the difference between this answer and this answer is that here we are printing the contents of a variable, which if we go back to the slide deck, we can see that, so what we're doing in Scratch is we are using a variable called lives, and we're printing the contents of that variable. Printing lives in between speech marks literally prints the word lives. Okay, so that's the difference. So whereas this one prints the contents of the variable lives, this one prints that word itself. Okay, so we can draw out this misconception around the difference between strings and variables. Okay, let's have a look at another equivalency. So I'm going to open voting on this one now. So here we have some Python, and we have 3 blocks of Scratch. Okay, which of those blocks of Scratch, or chunks of Scratch, should I say, do we think is equivalent to that chunk of Python? And I'm going to give you a short period of time to do this. So I'm going to give you, let's give you 30 seconds from now. So our first block says repeat 3, say hello. Our next block says forever say hello. And our next block says repeat 3, say hello. Now, even if you don't understand the Python code up here because you may not have written any, the idea is that we should be able to kind of look and have a bit of a guess between these two and see if we can work out what the equivalent statement is. Okay, so voting is now closed. Let's have a look and see where people went. Okay, so we're going to hide the image. Okay, we have an interesting result here. We still have a little bit of a split. nobody fell into the trap of going for the forever loop. So we're comfortable identifying the differences between a forever and a finite loop, which is great. And then here, what this is doing is this is saying repeat 3 times. And then over here, this one is saying repeat for the value contained in the variable called 3. So this here could be anything. This is not the number 3. This is a variable that I've horribly called 3. So in fact, this answer over here is the one that's equivalent. Okay. So let's have a go at another one. Let's have a one more question. So we'll go back to the slide deck and we'll have a look. We've got 3 more questions in total. Let's have a look at the next one. So I'm going to move that on, and here I have a pair of blocks. So I've got a chunk which says ask, would you like to play again? And wait, and then I set the response to answer. So which of those do we think is the equivalent block? And I'm not going to give you very long for this one. I'm going to give you, from this point forward, I'm going to give you 10 seconds from now for 5 answers, 6, 7 answers, 8, 10 answers, 11 answers. Voting is closed. Let's see how we did with that one. So let's hide the image and see what we get. So let's go into the deck. Okay, so answer equals input, would you like to play again? Which is great. That is the correct response, okay? And the interesting thing is here is if we go back to the slides, then the sort of the misconception here, or the thing we're trying to address, is how assignment works. So in Scratch, what we do is we put response, we put in the answer into response, but you might read that this way around, which is why some people have gone for B. What's actually happening here is we are getting the input in response to this question, and then the equal sign puts the result in the variable answer. So it's answer C and these 2 blocks, which are functionally equivalent. Okay, 2 more questions. I'm not going to revote. I get you to revote just in the interest of time. So let's have a look at our next question. So what's going on here? So which line of Python is equivalent to this block? And that is right, good, yeah. Okay, and I'm going to give you 30 seconds because I'm feeling generous on this one. So we've got 30 seconds to vote on this one. So is it lives equals -1, lives equals lives plus 1, lives -1, or lives equals lives -1? So what is happening in this block of Scratch code? Okay, voting is closed, and I've just noticed that for some reason there is a bit of a typo in my Menti poll here. I can see most people, lots of people have gone for D over here. Lots of people have gone for D, which is the correct answer. A few people have gone for this option here. Now, I'm not sure if that's because of the option they've seen on the Menti poll itself or on the slide. There's a bit of a mismatch there. Apologies, that's my fault. Let's just talk through these options and talk about why these other ones aren't the case. This one here, the one that 6 people have gone for, the reason that isn't the case is because this lives here is a lowercase l. So these are not the same 2 variables. Now I removed that option because I didn't want to trip you up. But let's go and look at the other options back on the slide deck, and we'll think about what students might be, what concepts we can sort of draw out of here. So some people might go for lives equals 1 because they think that this is changing lives to -1, which it's not. What this is doing is it is changing lives and it's taking 1 away. So that's why A isn't the case. A is setting lives to the value -1. This one here, apart from the fact that the 2 variables don't match, this one is adding 1. C is taking 1 away from lives but it never assigns it. It never puts it anywhere. It does a calculation and then forgets about it. Whereas this one does the full works. This one takes lives, takes one away from it, and stores the result in lives, replacing the original value. We're going to do one more. It's our last one, and then we really must move on to the next sort of few things that I want to talk about. So there's your question, and the poll is open. Now, this is quite a tricky one here, so I'm going to give you a little bit more time to do this one. I'm going to give you, let's say, I'll give you about 30 seconds from now. So we have a whole chunk of code there, which is consisting of quite a few elements. So we are saying, we're asking, what is 12 times 12? And then we wait for an answer from the user. We ask if the response is equal to 144, then we say correct, because that is what 12 times 12 is. Otherwise, or else, we say incorrect. Okay, seems I didn't give you very much time for that one. So I'm just going to reopen voting to allow a few more people to submit their votes. If you haven't put your vote in, do put your vote in, even if it's a guess. Have a go. There's no harm in getting it wrong. There we go. There's a few more votes coming in now. 5 votes, 6 votes. Great. And let's have a look and see how we've fared with that one. So let's switch over. Okay, so we have we have a bit of a split here. Okay, this is good. Okay, so those polls are moving around a little bit now as well. So let's have a look at this. So A, okay, I'm just going to read that one back. So A was in fact the correct answer. Okay, and let's have a look at why the other ones were not correct. So let's go back to the slides and we'll have a look here. So here, here there is an issue with indentation. And so if we look at Scratch, Scratch really helpfully wraps these blocks up and slightly indents them. And the same is necessary within Python. So this would not work because this print line is not indented. Python, in this case, cares about indentation. Other languages use other forms to kind of look to signify the conditional blocks, but here this would not work because print is not indented. C is wrong purely because I've messed the logic around here. So here we're saying if the response is 144, and I've just noticed a syntax error in my code, which we're just going to gloss over. If response is 144, then I'm saying it's incorrect. And if you get it, if you don't say 144, then you get it correct. So that's wrong. And the reason this one isn't working is that response equals print. Here I'm displaying the question, but I'm not collecting input. This is the only one that is correct because it is getting the input, storing it as response. The bit that's wrong for anyone that knows any Python is that this equals has a different meaning. That should be equals equals there. So there is a syntax error in my code, but nobody's mentioned that, or maybe people have. I've got 4 questions waiting. Who's pointing out my code? Okay, well, a couple of issues. Questions not open for voting or questions not appearing. Okay, if I change questions with Menti, up at the top it should say the presenter has changed the question. Go to that slide. Okay, so the point of that exercise was to really draw out the importance and the learning opportunities for just comparing Scratch and Python code together and really thinking about the concepts that lie behind them. But there's a whole load of other stuff that's coupled with this, that's all about your learners' needs. Okay, so we've talked a little bit about the languages and the specifics of the language, but our learners have needs that we need to address. And those needs are really important. So they present some challenges to your learners. Firstly, blocks require little typing or accurate spelling. Learners are used to engaging output, and someone pointed that out earlier on. And they will regularly make mistakes. And we're going to try and tackle each of these 3 issues. And we're going to have to do this a little bit quicker than I hoped because we're kind of a little bit tight on time. So let's sort of move ahead. So supporting typing and spelling. The first and probably one of the simplest ways of supporting this is by pairing your programmers. Having one person doing the programming and one person doing the driving at any one time, and getting those programmers to regularly swap. So one person's in the driving seat and one person is navigating the activity. And this means that your learners can support each other with those spellings. Coupled with that, you may also want to provide these keywords, particularly if you've got a language like Python where capitalization is important. Here, I've capitalized true and false because when we use those as keywords in Python, we use them capitalized. You can also enrich this with classroom displays. Why not take some of those code equivalences that we've drawn out in that previous activity, display them next to each other, and ask the learners questions about them on your displays. Refer to your displays and the concepts behind them when you're working on this transition. Template code is really helpful. I think this really is really helpful if you've got students that find typing a real battle. If you provide half the code for them and they simply have to fill in the blanks or do a small part of that activity, then it means that they don't have to spend quite so long doing that typing, and they can really get to the crux of the learning. And finally, quite often when you're writing, a lot of the experience that students have of writing is from word processing tools, which have a myriad of formatting options, and they can put pictures in and all sorts. Using a simple editor like Notepad or Idle, if you're working in Python, just cuts away a lot of that distraction and allows the students to focus on the text as opposed to what the text looks like. So I think there's a few really good ideas there for supporting typing and spelling. And if you as educators have any other ideas, please feel free to add those to the question dialogue, and I will share those with the group. But there's also something, and someone mentioned this earlier on, about expectations. This is a real challenge. How do we manage those expectations? Scratch and other tools like it is really good at giving students rich media artifacts from very few blocks. And conversely, with Python, the core output is text. And if you want to add additional media, it adds complexity. And quite often you have to understand how objects or methods or functions work just to get pictures or sounds displayed or interacted with. So that's a challenge. Scratch has concurrency built in, which means that if I have two scripts and within my program and I run my program, those two scripts run in parallel together at the same time. To do the same in Python requires extra programming. You have to build that concurrency, as Python assumes most of the time you don't need that. And if you need it, you're going to write the code to do it yourself. And finally, students can often once they've done Scratch for a very long time and they've written some really, really complicated projects with Scratch, they might get this mindset that Scratch does everything, whereas Python does less, but for more work. It feels like a step backwards. And I think that there's one sort of answer that I would really recommend people sort of think about when they're doing this, and one way of managing some of these expectations is there is a little bit of actually kind of having to say to the students, look, we are learning something that is more challenging. It is going to be a bit of a challenge. We are going to have to take a step backwards, but also there are ways of enriching that experience through projects, and projects using libraries that pre-exist to help you bridge this gap. So by projects, I mean finding activities which either give them opportunities to create media-rich artifacts. They may have to add some more blocks, but they're creating rich artifacts. There are ways of building concurrency in through the projects you use. And some of these projects and libraries may allow you to explore things that Scratch doesn't do that Python gives you the power to do. And so just a few examples of these. So physical computing is something we're really passionate about here at the Foundation. And we can do a lot of that through Scratch, but we can also do loads of really powerful things through GPIO 0. And there are things in there that Scratch can't do. We can do things concurrently, and we're breaking out into a new medium, the physical world. We can create GUIs, and a colleague of mine, Laura, has spent a lot of time working on how we can make GUIs really simple. And it's one of these a plethora of libraries that have the suffix of 0. We have GPIO 0 and GUI 0, and I'm not going to stop there. There's going to be a bit of a theme here. But GUI 0 is designed to take what can be quite a complicated task and make it as simple as you possibly can in a Python environment. Games and graphics we can tackle through something called Pygame Zero again. And Pygame Zero allows you to make games and media-rich artifacts, but it strips away some of the complexity and tries to make it closer to Scratch-like experience. And we can connect with websites and pull data down from them using a library called requests. We can interact with social media. We can send tweets, we can watch for tweets, and we can post and do all sorts of things with social media through Python with a library called Twython. We can interact with the network using a tool called Network Zero. And then we've also got things like data plotting using a library called Matplotlib. And these are just some of the many, many, many libraries out there that people have written to make engaging projects. And I think that actually using libraries, using these tools to extend your Python program is a really great way of bridging this gap and managing your expectations and providing engaging activities for your students. Conscious of time, I'm going to talk a little bit about resilience. And then we're gonna wrap up. So resilience is really, really important. And a few people within the barriers question earlier on identified this. How do we encourage our students to work through their problems? They're going to fail loads. It's going to happen, and it's a really important part of learning. We want our students and ourselves to fail and learn from it. And this is something that's important for you as the educator as well. You have to be able to brush the failure off, move past it, and learn from it. Encourage growth mindset with students. You often hear, I can't do this, or I can't do this, miss. And all you have to do, or one of the ways you can challenge that is just add the word yet to the end of that statement. You can't do that yet. Everything takes time. Reflect on early experiences that they've had. Tying their shoelaces took them many, many attempts. Learning to walk is something they had to spend a long time learning. Just because they can write now does not mean they've always been able to do that. Everything takes time and persistence. And therefore, it's really important to praise effort and persistence necessarily over results and performance. It's really important that the students try and persist and keep that energy and effort going. And failure alone is not enough. We have to learn from the failure. So how can we identify other strategies that we can use with our learners to learn from that failure? So questioning is really important here. What went wrong? Why did it go wrong? What could we have done differently? Is it something that we've done, or is it the part of the program? Is it something in the instructions? Where's the failure come from? And discussing failure without assigning blame is a really important part of that. And then I really wanted just to add a bit of literature to that, and not sort of high literature like research, but interesting things to engage your learners with around this, particularly with young learners. These books are great, and I've used many of these with learners, with my daughter, and these are really great ways of instilling a kind of a sort of a growth mindset, resilience to failure, and this idea that your brain is elastic and flexible, and it's like a muscle that you have to exercise and train to learn new things. So that is a really important piece of this, and I think that those bits should be given equal weight to the language and the technicalities and the concepts that we're trying to teach. So in summary, I'm going to wrap up our 40-minute session now, which has maybe gone on to 50 minutes, but there we go. So progressing from Scratch to Python, or from any block-based to text-based language, it can represent a significant challenge for learners, and we cannot underestimate how much of a challenge that is. However, if we can identify conceptual equivalences between the languages and find ways to help the learner bridge that gap, whether it's through the vocabulary that we use or exercises away from the computers pointing out the conceptual equivalence, then we can work on supporting them and scaffolding them as they move from one language to another. And we've also talked a little bit about, within that, we've talked about finding engaging projects which show the power of text-based languages over the simplicity of Scratch. And finally, we can't underestimate what the learners bring to this problem. They need the right scaffolding, they need the right environment, and they need the encouragement and the support in order to support. It's not just about the learners, it's about the mindset and the experience and the confidence that our learners bring to this challenge. So thank you very much for listening to me talk for a little while, and thank you very much for participating in our Menti poll. I'm going to leave the Menti poll open now, and we have one final question in there, which was, we would really like to have a little bit of feedback about how you found this session today. We're really passionate about doing these kind of synchronous sessions and working with educators, and we want to know how you find them and how we can improve them. So there's a short survey there to rate our session today on 4 different criteria. And then there's also, I'll unlock it so you can move to the next question, where you can provide any broad feedback that you want to via the Ask a Question, under those questions for you to answer. So thank you very much for participating in today's live learning. We'll be seeing you again in about a month's time. We have another session. We'll be sending details about that out shortly. Thank you very much. Bye-bye.